Welcome to Technician's Toolbox. In this episode we are going to be discussing a popular concern with a popular vehicle. No HVAC blower output on the late 90's Cadillac with auto HVAC systems. This is a relatively simple system to diagnose and repair if the technician understands exactly how the system works and also has the proper tools to diagnose it. Here's a view of the control panel. If the auto button is selected, the blower fan will operate automatically based on the various inputs of the system. If the top arrow of the fan control button is depressed once, the blower fan speed will increase slightly and the climate control panel will display High Auto. The blower fan will operate automatically, similar to the auto settings, except at a slightly faster speed. If the fan button is depressed twice, the fan will always run at a fixed high rate of speed, and High will be displayed on the climate control panel. This is an override of the automatic fan speed control. If the bottom arrow of the fan control button is depressed once, the blower fan speed will decrease slightly, and the climate control panel will display Auto Low. The blower fan will operate automatically, similar to the auto settings, except at a slightly slower speed. If the fan button is depressed twice, the fan will always run at a fixed low rate of speed, and Low will be displayed on the climate control panel. This, similar to the High setting, is also an override of the automatic fan speed control. Depressing the auto button will return the blower fan speed control to the initial automatic operation. Depressing either the top or bottom fan button will shift the blower fan speed control upward or downward through the additional automatic operations. The troubleshooting flowchart for the system starts by directing the user to look at the scan tool to verify the blower control is actually sending the proper command signal. A reading of 99 should be indicated when the high speed is selected. As the speed request is lowered, the count should also be lowered down to around 30, which is full off. If the commands are as desired, the flowchart directs the user to measure the resistance of the circuits and the motor, then replace components as required. This method is not only time-consuming, but it also requires the use of the factory scan tool, which not everybody has. There are also faster and more direct methods to test this system. Here we're looking at the schematic for the front blower and control system. As we can see, a 50 amp maxi fuse supplies power at all times to circuit 542, the red wire. Ground is supplied from the black wire, which is circuit 50. So far so good, right? We should have B plus on the red wire and ground on the black wire. Circuit 754, the gray wire, supplies an input command to the blower motor from the HVAC controller. Nowhere in service information does it explain what type of signal to expect in the circuit or how to test it. If we look at the box inside the blower motor portion of the schematic, we can see a square wave drawn. This indicates that the blower controller sends a pulse width modulated signal to the blower motor, which then controls the ground side of the motor. One important note when testing these systems is that the vehicle must be running. As we see here, a lab scope makes this diagnostic procedure easier. In this particular capture, the technician has the car running, the blower speed set on low, and has his lab scope back probed at the blower motor connector, which is still plugged in. Channel A, displayed in blue, is connected to the control signal. Channel B, displayed in red, is connected to the supply voltage. Channel C, which is displayed in green, is connected to the ground signal. As the image displays, we can see we have proper power, ground, and also a control signal displayed as a square wave. Here's a picture of that same test using a DVOM back probed on the signal wire. This is done after the technician has already verified proper B plus and ground on the other two terminals. Even though we have a signal that is pulsed between B plus and ground, the DVOM is displaying 2.67 volts. The DVOM actually gives us an average reading of what it is actually seeing. Here's another view with a lab scope. At this point, the technician has changed the control setting to a high speed. As we can see, the command signal is spending more time at ground than it is on the positive side, indicating its attempt to speed up the blower motor. Once again, here's another look with the DVOM. As we can see, the ground command is greater than it was before. By using these tests, the technician is now confident that the blower motor is receiving power, ground, and a command signal. He's also confident in the controller's ability to send varying signals to command varying speeds. This is very important before selling an expensive component that also may be labor intensive to replace. The picture shown here shows the old blower motor on the left and an updated unit on the right. The updated unit also comes with a tin shield to protect it from stray secondary ignition voltage, since the spark plug wires pass in front of it. Thanks for tuning in today. Hopefully you now have a better direction when diagnosing one of these units.